Okay then, so last time we took our first look at integral calculus, and now we're going to extend that a little bit by looking at how we can evaluate and actually use integral calculus to evaluate what's called definite integrals. And the introduction to assignment 2 has already been carried out. So up until now, we've integrated functions to obtain what's called an indefinite integral that includes a constant of integration. We can only find out the value of that constant of integration if we have more information about the function. Usually one of its value when the variable is equal to a certain variable. So if you know what function is equal to when x is 1, you can put that value in and find out what the constant is. Also, it can be evaluated, and the constant of integration will be not become a problem when we solve what's called the definite integral, where we apply limits. So, for example, if we want to know the value of the integral of x squared with respect to x, as x increases between 1 and 3, those two numbers are called the limits. We write that definite integral like this. So we use the integral sign. We put the upper limit at the top of the integral sign and the lower limit at the bottom. And then we write the function and dot dx afterwards. Okay, so as soon as you see limits like this, you're working with a definite integral as opposed to an indefinite integral. So if we look at how we would evaluate that integral, the first thing we do is we integrate the function and place it in brackets with its limits. So if we integrate x squared, the method is to add 1 to the index and divide by the new index. So we end up with x cubed over 3 plus c. Yeah, so what we've done is we put that in some brackets. The shape of the brackets is not significant. I just try and use some different styles. Square ones are most common. And then at the top there, we put the upper limit, and the bottom, we put the lower limit. Then the value of that function is equal to the function with the value of the upper limit, 3, take away the value of the function with the lower limit, 1. So what we do is we take these two here and we put in to the function these two values, 3 and 1. So that's in that one, we've put in value x equals 3. And in this one, the value x equals 1. Okay, and then when we and this slide's gone off a little bit, I'll take this up here. So we end up with 3 cubed over 3, yeah, must be 9 plus c in the first bracket, or for this one, that's 9 plus c. Yeah, this one is 1 cubed, which is 1, so that's minus 1/3, 1 over 3 plus c. Yeah. Now the important thing here is that c take away c equals 0. So when we evaluate definite integrals, the constants of integration always cancel out. I've put them in this example so that you can see how they cancel out. But if you're evaluating a definite integral, at this stage, you can just leave them out. Constants of integration always cancel when you evaluate a definite integral. So the answer to this is 9 minus 1/3 equals 8 2/3. Okay? Everybody follow that reasonably well. Okay? Is anybody saying they haven't got this handout? Is that what you're saying?
No, I
Regan?
think they're talking about other handouts just to help with the assignment.
Yeah, everything up until right up to last week is our Moodle. Right?
Yeah, I don't handout.
Sorry?
I don't think I've been sent this handout. I can't find it in my emails.
That's Jake.
What's
Yeah.
your email, Jake? I'll send it right now for you.
I'll send you a text.
Well, actually, I found it.
Thank you, Dom.
Anybody else not got it? Because I definitely sent it out. Obviously, Dom's got it, so.
Jake, you are in the email. Jake.honey@BT Internet.
GG.
Right, can we carry on now? Is everybody happy?
Proceed with caution.
Right, proceed with caution. Dom said. Right, we're going to have a look. I'm going to work through a couple of examples now. Evaluate the integral between 2 and 1 of 3x dx. Yep. So the first thing we need to do is integrate this into some brackets. So as we know, what really we can do is, if we want to, is take this constant outside. Yeah. That might help us to, so therefore that constant comes outside these brackets. So that was a constant multiplier rule that we looked at last week. Okay. And then if we take is x to the 1, so it must go x to the 2 over 2. Yeah. And then it's between, we can ignore the constant of integration because they cancel. We got to evaluate between x is 2 and x is 1. Yeah. So we can say that is 3, open one set of brackets, times x squared over 2 when x is 2, take away x squared over 2 when x is 1. Close all the brackets. All following so far? So we then go equals 3. and then x is equal to 2, so that's 2 to the power 2 over 2 minus 1 to the power 2 over 2. Close all our brackets up. It is 3 times 2 squared is 4 divided by 2, which is 2, minus 1 squared is 1 over 2 minus a half. Yeah, and 3 times 2, 1.5 is equal to 4.5. Okay, everybody follow that? All right. No dissenting voices. Good. Right. I'm going to start a new page for me to have a look at the other problem. So we've got one with a negative. So we're evaluating, this is B, we're evaluating the integral between 3 and minus 2 of 4 minus x squared dx. Yep. That's going to equal, so we have to integrate 4, which when we integrate a constant, the variable of integration comes back, so we end up with 4x. That becomes x cubed over 3. Add 1 to the index, divide by the new index. Just to clarify and remind you, this one here is we could write as 4x to the 0, and then when we integrate, it becomes 4x to the 1 over 1, which is 4x. Just to show you where that constant of integration comes back when we integrate a constant. Close the brackets and put our limits in, which are 3 and minus 2. So that's integrated the function. Now we're going to evaluate it. Notice the constants of integration have been ignored. This is 4x minus x cubed over 3 when x is 3. Take away 4x minus x cubed over 3 when x is minus 2. Yeah. Evaluate the first bracket. That's 12 minus 9. Take away, this is 4 times minus 2 is minus 8. Minus minus 8 over 3. To be careful with your signs here and make sure you evaluate these brackets carefully, because this one is 3, and then that's minus minus 5 1/3. So the two negatives become a plus. Sorry about that. And the final answer is 8 1/3. And I do put a lot of value in keeping these, evaluating these brackets separately and being very careful with the signs, when you square a negative number, be very careful that the cube and this -2 here, that it is -2 all cubed when you put that in your calculator. Yeah. Okay. All reasonably happy with that. Good. Right. Let's have a look at one with trigonometric function. Now, one thing to remind you about with calculus and trigonometrical functions, sine, cosine, and tangent, is that your calculator, any angles must be dealt with in radians, always, no degrees for calculus. All right, so we're going to have a look at this one, evaluate between the limits 2 and 1 of 4 cos 3t dt. Yeah. So what is the first thing we could do is take 4 as a constant multiple outside integral. Yeah. And when we integrate cos 3t, what do we get as integration? Anyone remember or look at that table?
The sin in it.
Yeah, it involves sine, yes. Is it negative or positive? What exactly do I write now? I need 4 outside. So hang on. What is that? This number here, the 3, is a. I think for cos ax, the integral is 1 over a sine ax, is it not?
Yeah.
Yeah. So you want 1 over 3 sine 3t between 1 and 2. And that's 1 radian and 2 radians, yeah? All right. So it's equal to 4 times a third sine 3t, and t is 2. Take away third sine 3t, and t is 1. Close the outside brackets. All happy with that? So what you're going to evaluate in your calculator is 4 outside brackets 1/3 sine 3 times 2. Calculator in radians, remember. take away 1/3 sine 3 times 1. Close the brackets, close the outside brackets. Yeah. And if you're evaluating that in your calculator, you should get, just check it, minus 0.5607. Okay. Have you checked it? Anybody checked it? Just make sure. Help to confirm your calculator is correctly in radians mode.
I've just got 0.
What have you put in your calculator? That's a third. That's 4 overall. A third sine 6. Third times sine 6. Take away a third times sine 3.
Mike, the second half of the equation, you know where it says sine 3 and then brackets 2, should that not just be sine 3?
That's 1. Sine 3 times 1. That's my writing.
Sorry.
That's not easy on this screen. I'll make it look clearer. That's 1.
Perfect.
Yeah, if that's 2 as well, Regan, that's gonna end up as 0, isn't it? Because you're doing third the sine of 6 minus third the sine of 6. But
Yeah.
I apologise. I'll try and make it clearer.
No, you're alright. It's probably just me.
1. Yeah. Because you're putting in this value 1 up the top here, aren't you? The value, the lower limit value.
Yeah, you're replacing that with t, aren't you?
Yeah. Placing t with that lower limit up there.
Yeah.
Yeah.
Yeah, perfect. Thanks.
So you should now get minus 0.5607. Hi Nathan, you found us then.
Yeah, I had to sort something out with my boss before.
That's no problem, Nathan. I was just surprised because you're normally one of the first here. That's fine.
I would have let you know, but he just rung me out of the blue. So
that's all right. No worries. Did you hear any of the assignment introduction then?
No.
I'm putting that separately on Moodle. I'll send you all a link to it anyway.
Okay. Right. Does that go through the assignment?
Yeah, go through and which tasks are past tasks.
Okay. All right. Cheers.
All right. Sure, you could get them off your learner mates anyway, but you know that will be there. Okay.
Okay.
Right. Everybody happy to move on? Good. Right. So as you can see, we're just having a look at all the kind of different functions we might come across first, and then I'm going to get you to try some. So we're going to look now at doing the integral of between 2 and 1 of 4e to the 2x dx. So first thing we can do, as always, is take a constant 4 outside the integral. And then we're going to integrate e to the power of 2x dx. Yeah. So the first thing I can do is say that equals 4. Mustn't forget our constant multiplier times. And then what happens when I integrate e to the power of 2x? That's e to the ax in your table. Anybody? Is it not a e to the ax? You got your table of integrals handy? If we integrate e to the ax, 1 over a e to the ax, so it should be 1 over 2. 1 over a. So here we're going the 2x. Yeah. And then close our brackets and put our limits in, which are 2 and 1. Okay. So that equals 4 times half e to the 2s 2 minus half e to the 2x and x is 1. Close the brackets. Yeah, that's 4 half e to the 2 times 2 minus half e to the 2 times 1. Yeah, and if you put that in your calculator, you should get 94.42 or thereabouts. Okay. Right. And lastly, we'll have a look at one. The part B, which is integrate between 4 and 1, 3 over 4u du. Yep. So what we can do is, first of all, is take a constant out, which is 3 over 4, between 4 and 1, of 1 over u du. That equals the 3/4 outside the brackets times, and if we integrate 1 over a variable in a table, we get ln. So integrate 1 over x, we get ln x. So this is 3/4 of ln u between 4 and 1. That equals 3/4 of ln 4 when u is, hang on, I'm one step ahead of myself. ln u when u is 4 minus ln u when u is 1. Close the outside brackets. Three-quarters of ln 4 minus ln 1. And if you plug that in your calculators, you should get 1.040.
Mike?
Yeah.
When you went from the first equation to the second line, where did the u go on the 3/4?
That's
You've lost like
what
the
we've
u.
done. That's here. It's underneath. This is u. Did it not look like u?
No, I just didn't know why it left the 3/4.
Because what we're doing is simplifying by taking the constant 3/4 outside the integral.
Okay.
So 3/4 has gone there. Yeah.
And that's left on the u, and you have to put it as 1 over.
1 over, yeah, because what you're saying is 3/4 times 1 over u is equal to 3 over 4u, isn't it?
Okay.
Yeah. What we're saying, if we multiply these,
yeah, I get that now.
this
Yeah.
1 over u by 3/4 back together, we end up back where we started. All right. And you don't
Yeah,
have
no worries.
to take,
Thanks.
you don't have to take the constant multiplier out, and sometimes that can be a little bit easier leaving it in, but you only kind of get used to that when you're done a good few examples, and you get a feel for when That's easy. That'll simplify more if you leave it in to
Okay.
start with. All right.
Yeah,
Yeah.
thanks.
Just check that answer and then make sure that's what you get, so you know you're using your calculator right. All happy?
Yeah.
Right. On the final page of your handouts before your table of integrals and things, there are 4 examples. Well, there's actually 8 examples because there's 2 in each question for you to have a go at on your own. Give me a shout if you get stuck, and we can always go through. The answers you should get are in the brackets. Yeah, on the right. So I'm going to pause the recording and give me a shout if you're struggling.